Hello and good evening, everybody, and welcome at another edition of the Laravel Worldwide Meetup. I'm very glad that all of you are here. Like previous episodes, we have two interesting guests. In a little while, Stefan Baumgartner will join us, and he will talk about TypeScript. If you've never worked with TypeScript, this is going to blow your mind. Certainly, if you love types, you will absolutely love it. But my first guest this evening is Frank de Jonge. And Frank, he is the guy that brought you the magic of Flysystem. Let me bring him on. Hello, good evening, Frank.
Hey, how's things?
All's pretty well, and I hope in Holland everything's fine as well. Given the circumstances.
As fine as it can be.
As fine as it can be, yeah.
Yeah, it's about 25 degrees hotter than it was last week. So in terms of temperature, things are looking up.
Yeah, that's pretty good. But we're not going to talk about the weather, right? We're going to talk about Flysystem.
Definitely. Yeah.
What do we have in store for us, Frank? What are you going to talk about?
Well, tonight I want to give a little bit of a background on the changes and the reasoning behind V2 of Flysystem effectively. So a little bit of looking back at V1 and looking ahead at V2, seeing what the differences are and why they came about.
Cool. Looking forward to it. I think like most Laravel users, I've enjoyed version 1 of Flysystem for so long now. And it's a little bit, it's a cool thing about Flysystem is that, it just works. I don't have to worry about file systems anymore. I still remember that, I think about 5 years ago, right before you released like a first version of it, I had to deal with like FTP connections on my own, and it was hell. So thank you from me and of all of us in the Laravel ecosystem that we don't have to go through that pain again.
Yeah, well, if you talk about the FTP file systems, this was one of the primary use cases for me as well. And I thought, I'll create Flysystem or an abstraction for this one, so I'll never have to deal with FTP ever again. Well, joke's on me, because now I'm the only guy actually dealing with FTP. But I'm glad I can take that pain away from you, Frank, and the rest of the Laravel community.
Okay, man. I'm ready to hear what you have in store for us for V2. So take it away.
All right. I should be
Let me add your screen. Yep.
There we go.
Have fun, Frank.
Thank you. All right, so as I said, today I'm going to talk a little bit about V2, a little bit of what V1 was all about, and a little bit of where V2 has headed, just to get sort of a sense for you what kind of thought went in behind it, and maybe looking at V1 and some design mistakes as well. All right, let me see. So first of all, a little bit about me. My name is Frank de Jonge, as Frank correctly pronounced. Of course, in speaking Dutch, he just got a one-up on that. I'm a staff engineer at Molly Payments, which means I work at the payments company. We process payments in PHP. Of course, we're always looking for talented new people. We're still hiring, more so than ever, I think, actually. So if you're looking for something exciting new and you've got what it takes, then, of course, hit me up. I'm also the guy behind Flysystem and Event Sauce, and Flysystem is the reason why I'm here today. And if you look at Flysystem over the last couple of years, it's just been incredible. Like the adoption, the continuous growth. And this basically all started, this graph doesn't really show it, but if you zoom more into the Laravel, I think 4 release, when Flysystem first shipped, you could just see the downloads hockey sticking right off the bat. So if you look at the success of Flysystem, this is really just all thanks to the success of Laravel and the continued adoption and appreciation from the Laravel community. So first of all, I want to thank you all for that, to keep embracing Flysystem. That said, if I look back at the last couple of years, if you create a package, and I've been maintaining this for years, and apart from all the successes, there have been some mistakes that I've made, and those mistakes are a couple of design decisions. And what keeps happening over and over and over is that if you're the one maintaining this package, new users come in, they run into the same kind of errors. But me, myself, I go into places as well where I join companies that have used Flysystem before, and I see the same patterns over and over. And I'm like, although I'm really glad and grateful for the success, sometimes these errors that I've made, I also get slapped in the face for a very long time because of that. So for V2, this is something that I wanted to sort of say goodbye to. I wanted to fix the mistakes of the past. So if I look at the mistakes of the past, there's a couple of ones that I want to talk about today. The first one is repeated patterns in consumer code. This is where some design decisions for me made sure that everybody is writing the same code over and over and over. I didn't like that. The second one is unhappy paths. There is actually 2 of them, and that's not really ideal because that means you have to test more. Some of the design decisions also made my IDE not very happy. Well, I'm like the next speaker, I'm all about types, and more about types helping me to not have to remember everything about the system, but really the type system helps me understand and move through and navigate the system. That's what I like about it. And it was sometimes difficult to get static analysis running in these cases as well. So all of these things I wanted to address. So if I go over the things that I did while doing so, I think I rewrote Flysystem about 4 times before going public with V2. And one of the things that was really important was the refocused project vision for me. I wanted to sort of get back to the roots of what Flysystem was really about initially. I want to also show a reduced API, some fancy things that we've done for error handling and content listings. And then lastly, I want to go into the composable extensions. That's also a part that's new in Flysystem that you might not see. So the first thing is a refocused project vision. So what does that mean? Well, I wanted to go back to why Flysystem initially was created. So as I said in the introduction, one of my first use cases was to be able to use an abstraction over FTP because FTP was, not really enjoyable to work with. And I actually had a case where I needed to code against a file system, an FTP server, and this was had a whitelist. So what happened is, if I wasn't at the office, I couldn't develop any features. So what I did is create an abstraction and make sure that there's feature parity between the 2 implementations. And this was sort of the first iteration of Flysystem. But it was all about file storage. But of course, as time moves on, people have feature requests and everything just happens. So people started adding feature requests and they wanted to get more specific features from basically every storage engine that was there. But this kind of defeats the purpose, right? It should not be a full API of every storage mechanism ever. This would mean that it's basically just a duplicate of everything else. And the value in having abstraction is that it streamlines and unifies. So this is something that I really wanted to prevent. Secondly, if you look at an abstraction, it should hide implementation details, right? This is important. I think we already did a very good job in V1 in doing that. For example, this is one of the reasons why all the roots are relative. and all the responses and requests towards the abstraction are normalized. So you don't have any specific return values that indicate that something is from AWS S3, for example. Well, sometimes this kind of leaked through in V1. In V2, this is neatly taken care of. This is partly done by the test suite, where we've got an abstract test suite that makes sure that all the test cases for every file system are uniform. Of course, there are some special cases for every file system in terms of errors, but mostly the happy paths, they all act the same, and they are now guarded against. So this is really nice. Something that I think Laravel itself got better than Flysystem initially did, is separate file systems and file storage. If you look at Flysystem, which is of course a sort of punny way to say file system, it hints at file system. So people might have had the interpretation that this was actually about file systems. Well, it's not. It's more about file storage, and the storage facade that Laravel uses, I would say, is even a better name than Flysystem itself, because it communicates a better purpose of what the library is about. So we also want to go back to that. So keep that as a basis. In terms of the usages that have been changed, one of the biggest things that you'll notice is that there's a reduced API. And I'll show a little bit about that, about why that is the case, and why it is okay to have less methods in V2 of Flysystem. So I want you to look at this piece of code. If you know the behavior of Flysystem by heart, you know that if you update a file, it will first check if there's a file, and if not, then it will throw an exception. The same is for write, but it then will do the inverse. So it will check for the absence of a file, and if that's not true, so if there is a file, it will throw an exception. So if you look at consumer code, you mostly see this, where you first have to do a hash check, and then if there is a file, then you need to update it, and if there's not a file, then you can write, right? And this is something that I saw being repeated over and over, and I didn't like it. But more so than not liking it. Oh, wait a minute. Yeah, there we are. More so, this is also a huge performance bottleneck, because if you do the hash check, if you do, for example, you integrate with AWS S3, this is an API call. Then the second call is being made for the update, but it's actually not one call. It is internally, it does a hash call, and then it does the update call. And then, so in total, you now have 3. And this is true for both branches. So the ironic thing is you have 3 API calls right now, but internally, what the file system does is use the exact same HTTP call to write or overwrite the file. So 2 out of the 3 calls are absolutely useless. So this is why I wanted to get a new heuristic about writing files, and that is writes always overwrite, and therefore we remove the need for the update method. So this means the update method is gone. So that means we go from this to only this. There is now only one file or one method to write files, and it will by default overwrite. And this is one API call. So that means you've saved 2 out of 3 API calls. If you look at the API then, this removes the update method, the update stream, the put, and the put stream method. And the put stream, some people might remember that or have even used that. This was the method that on the file system layer allowed you to basically have the same behavior, not care about writing or updating. Well, the funny thing is, actually, internally, it did this hash call and then delegated to write and update. So it was sort of well, I've characterized it before as a sort of a performance degradation as a service. This is just something because of the design that we had, we tried to mitigate with the UI, but it had a serious performance degradation. So that's something that we now completely got rid of. The second thing that was improved was error handling. This was also a huge grievance of me every time I worked with the library myself. If you look at Flysystem, you mostly use it like this. Hey, I'm going to write a file and I'm going to get back a result. And if there's not if the result is not true, then there's an error. Well, this was effectively only half the story. So in certain cases, if there was an unexpected error, you would actually get an exception. So that meant that you would have to wrap this code with the try-catch loop and catch that exception. And now, if you look at this, you've got two paths that have an error. Well, this is, of course, not nice, and we want to get rid of it. So in Flysystem v2, everything is now just an exception. So you never get success responses anymore. The only thing that you get back, if there's an error, you get an exception. This has a lot of benefits, but one of the benefits is that it's clear what's happening. So here you see we're unable to write a file, but we've got this for other methods as well. So if you're copying, we're getting an unable to copy file exception. Underneath, there's a base type that you can also hint against, so you don't need to catch everything with a specific name, but you're able to. So this allows you to distinguish at an error reporting level what went wrong and why. So the same for move, and we've got another couple cases. So there's a couple benefits to this. One, we have reduced one unhappy path, so we only have one. But the nice thing about PHP is that if you have an exception, and exceptions allow you to wrap other exceptions, and if you do so, you maintain the backtrace of all these exceptions. So this means for logging and monitoring, and for error reporting, you get the full context of what went wrong. If you look at V1, V1 was basically a black box sometime. And sometimes it would leak exceptions through from the specific adapter that you used. And this, of course, breaks the encapsulation boundary of what the abstraction provides. So now that's no longer the case. I quite like the expressiveness of the exception. So it really states, it's not like file system exception and then something else, but it really states what kind of exception actually happened. Content listings were also improved. And the reason for this, well, there's a couple of reasons for it. One of the things that happened often is that people were running out of memory when they were listing contents. So this has to do with the return type of the contents listing. If you look at it, the contents listing is in itself an array, and then it returns more arrays. So this, what this means underneath is that you need to accumulate all the information in order for you to return the full listing. So this means that if you have an extremely large directory, that you would accumulate all the memory in your system, with the last loop of trying to resolve what is in that directory would run out of memory, and this would cause an exception. Of course, when people see an exception and Flysystem is in the stack trace, they go back to me. So then I'm left to fix it again. Well, we fixed it by using generators. But there's a different thing. If you're looking at this content listing, well, you see an array is being returned. We list the contents, and then we check if something is a file or not, and then we use something. But what is this response actually? Well, by now I think people know by heart what kind of keys there are. So that is sort of okay, but you never know for sure. As I explained before, the response is also not super memory efficient, because you need to accumulate everything before being able to return it. So now what we've used generators instead. In addition to that, all of the returned objects, well, they're objects now, so that's a difference. They're specific objects for files and directories. And they've got methods to indicate what kind of type they are. In addition, because we are now using generators, something that has also changed is there's a convenience layer quite similar to the Laravel lazy collection functionality. So what you can do is actually, instead of filtering in line in this loop, you can actually promote this to a filter. So if you have the content listing, you get back an object that's a content listing, and you can use filter in order to get whatever you need. In addition to that, much like Laravel itself, you can also map things. So if you really only need to know the paths of the files, well, here's an example of how that looks. I think it's a lot neater than the previous iteration, which is just a whole lot of messing around with arrays. So to summarize, content listings are now backed by generators. This makes them super memory efficient. We've got a class-based response that has some helpers, so that's pretty nice. And this even works with all kind of weirdly paginated responses. So some file systems internally, they have some mechanisms to paginate over response, and this in the background does multiple API calls, so multiple HTTP calls. And now when you're consuming it, you're not even noticing it, but while you're looping, those HTTP calls are being fired. So I think that's pretty magical. Not magical, nice, or not in the bad way, I see. So the last thing I want to highlight is the composable extensions. So in Flysystem v1, a lot of the standardization was around, well, there was a convention. And if you wanted to break the convention, you either needed to make an extension or you needed to duplicate the class. But there was no real solid way of influencing a certain behavior. And there was definitely a case for this. Flysystem v1 didn't really allow it. So for v2, I wanted to make it more accessible. So we're going to look at a couple of these. If you look at the reasoning why this was needed, well, you have different things that you want to have extended per file system. So it's not generic. So you won't find these in the generic namespace. You will find things in the adapter specific namespace. One of these sort of conventional things that we did was the visibility system. So if you used public or private for your visibility, for S3 it would translate to something that S3 can understand, and for your local file system it would use something based on unique file system permission. So if you wanted to change that, either you had to override this all. It was just a pain. So now we wanted to get interfaces in place so that you could actually create your own implementation of these specific point cuts. So for example, the Unix visibility converter. This is what the FTP and the local file system uses to convert back from visibility to the Unix permissions. So you can see here that if you would create your own implementation of this, you could do whatever. And for Flysystem just cares that this interface is satisfied. So this gives you all kind of freedom. So that's pretty cool, I think. If you look at, for example, AWS S3, well, you've got the same thing, but now you've got something that converts back into ACLs. So this is, again, something that's specific for the file system. So if there's a specific adapter for a file system, you will often see these specific point cuts that you can take. It's not just for visibility, though. If you look at, for example, SFTP, underneath we use PHP seclib. If you look at how to set up an SFTP connection, well, there's 1,000 sort of different flavors that you can use in order to set up an SFTP connection. Sometimes it doesn't even follow protocol. Sometimes there's double re-authentication routines that you have to do one thing, and that one thing fails, and then you have to do a second, first you do a primary key and then you do a password, but the primary key will fail and then the password will succeed if you do it in that order. So it's kind of a puzzle that you need to figure out. But in order to do that all in one go, it became really a big mess. And then sometimes, like, we got the majority of the cases right, but then still sometimes it wouldn't really fly. No pun intended. Well, okay, a little bit of pun intended. Now we've implemented this connection provider interface, and now you can actually create your own implementation of this. The same goes for the connectivity checks. So if you had an FTP connection, for example, the connection checker method that is most reliable is a raw list. So you do an FTP raw list, and that you do that of the main directory that you're in, because you can't do it off of a directory that does not exist. So you have to do it in a directory that you know exists. But there was a problem here. Some people had the home directory of the FTP server was a directory with a lot of files. So this means that you're actually doing a lot of I/O here, and you're waiting a long time for your response, only to see if there's a connection. Well, luckily, there is also such thing as a no-op. And a no-op is a command that you can send over FTP, and the FTP server will just acknowledge it. Well, FTP being FTP, this is of course not supported everywhere. So by default, we need to do the thing that is the best for everybody. But there was not really a point in Flysystem where we could interject. Well, now with V2, we have this. So this greatly improves that performance. Actually, I had what's it called? An issue on my GitHub profile that was actually related to an FTP performance issue, where the performance of writes would degrade until a single read actually would take about 2 seconds, while the first was almost instantaneous. With V2, those performance regressions are gone. So that's pretty nice. So coming back to it, we have a refocused project vision. There's a reduced API. We've got improved and more descriptive error handling. We've got some nice toolings around content listings and backed by generators, so a lot more memory efficient. And we've got a bunch of places where we can create our own implementation for certain specific behavior. So all in all, I hope that you will agree with me that V2 is a quite substantial improvement over V1. So that's, of course, Flysystem. And Flysystem V2 is out right now, and it's available for you to use. The only downside is that you can't use Flysystem right now with Laravel, because Laravel already requires V1 of Flysystem. So if you would try to connect to V2 or try to require it, it would throw an exception, and this would not be okay, of course. But I've made sure that just for the Laravel people, there's now a second distribution of Flysystem that will allow you to, next to your Flysystem V1, install Flysystem V2. So there is now a new package, and that's called League Flysystem V2 Preview. So the preview packages are just the same packages as V2 regular, but it's I created some tooling to rewrite some files and to change the composer.json to make sure that all the dependencies are figured out. And so these can just be run in parallel or be installed in parallel or next to the installation that you've already got. So in order to show you that, I will see if I can drag my editor into screen. There we go. And here we go. So I've got just to prove it to you all. I've here got an example app, just the regular example app that you get with a fresh install. And in this vendor folder, and I'm literally only just showing that, you see Flysystem v1 being installed. So this is all the stuff that you know. But in Flysystem v2, what you actually see is that you've got this, but then in a new namespace. So if you want to use it, you need to use the Flysystem v2 namespace, and then you can just use the same documentation as Flysystem v2 regularly, and make sure that you gradually update. All right. So with that, that's all the improvements that we've made for Flysystem v2. I really hope you enjoy it, and looking forward to seeing another round of adoption for this new major version. Thank you.
Pretty cool, Frank. Those are some sweet improvements that you've made. And it's certainly a very good idea to already have like a preview package so that people can toy around with it.
Yeah, when I got the news that the next version of Laravel would be 6 months behind, before I thought about it, but I thought, well, if I wait a little bit longer, then the normal adoption can start. But with this, people already can get their hands dirty on this and hopefully enjoy it.
Yeah, I'm pretty sure they will, because it's like the default thing to do when you need to connect to other file systems. So yeah, thanks, Frank. I guess that the full V2 version, it will be available in Laravel 9 in September, right?
Yeah, that's correct.
Okay, cool.
Yeah.
I'm pretty sure you're going to see a spike in your Composer installs then.
Absolutely, yeah, I hope so. Yeah. I think Dries did the upgrade, and I think he only needed a couple of hours even to create the abstraction around Flysystem v2, and there was almost no difference for the user in that regard. So I expect most of the upgrades to be very painless.
Yeah, and if it's a painless upgrade, maybe people don't appreciate your work because you've done your work well, and people don't have the pain. But let me thank you again for all the pain that you're suffering for us, Frank.
You're very welcome, Frank.
Okay, Frank. See you next time. Thanks again.
See you next time.
Okay, with that excellent first talk, we are going to take a little break. After the break, Stefan Baumgartner will join us to talk about the magic of TypeScript. And I've been looking forward to this talk myself quite a lot. So see you in a couple of minutes. Hello, everybody. I hope you enjoyed that little break. Let's get straight on to our second guest. Let me bring on Stefan Baumgartner. Hi, Stefan. Oh, wait, you are muted. I should unmute you. Now it's better, I think.
Okay.
Yeah.
Okay. All right. Okay. Hi, Freek. Hi, folks.
Perfect. Hey.
Cool.
Yeah, thanks so much for coming on, Stefan.
Thank you so much for inviting me.
Yeah, we talked a little bit earlier today, and you already said that yeah, you haven't done any PHP lately, or like in the past 10 years or so.
Lately, so I did check. I guess it was 20-something years ago. Seriously. So what I've seen just right now from Frank, he showed namespaces, classes, interfaces. I haven't seen anything of that. So
Okay.
That was pre-version 5. Where I wrote my last line of serious PHP. I did a little bit of WordPress in between, but you can't consider that writing PHP. You can consider that writing WordPress. But hey, that's about it. So lots of new stuff for me today.
Yeah, I think since version 4, PHP also gained a type system. And for some people, this is like the only only type system they know. But TypeScript goes a lot further, right?
Yeah, so you can do some rare things with TypeScript, and I hope that I'm going to blow a couple of minds today. So that would be my goal for today. Let's see if it works.
Okay, let's get started. I'd say, yeah,
Okay.
I've been looking forward to it. So let's go.
Let me share my screen.
Yes.
Let's see if that works. Alrighty, you should see. Whoops.
Here is the screen.
That's the screen. That's my slides. All right, cool. Great. Yeah. That looks good. Okay.
Have fun, Stefan.
Thank you very much, Rick. All right. So again, thank you so much for inviting me. I think this is a great opportunity. So I enjoyed it a lot, being invited by communities where I'm not actively involved in. And I've seen so many things from the Laravel community, especially from my friend Christoph Rumpel, who is very active in that community. So I speak a little bit, and I thought, okay, hey, you're doing great things. There's some great things going on. Lots of innovation that I can see here. But you know, I couldn't touch base with that. There's just so much going on. You know, tech is such a vast field. How would I be able to see and understand everything? But you know, it's interesting what you folks do, and I hope I can give you a little bit of insights what's happening in the TypeScript community, because that has experienced some tremendous updates in the last couple of years. Alrighty, so first about me. So I'm Stefan Baumgartner. Just as Frank said, I have the worst Twitter handle in the entire world. That's short for Dead Parrot. So if any Monty Python fans are around. And as I said earlier, so I haven't done any serious PHP development in more than 20 years. So back in the day, it was totally okay to map a get parameter and put it directly into the MySQL query that you had. And yeah, what could go wrong? Well, everything. So, and basically HD access was the one line of defense that we had. So everything is secure and safe with HD access, isn't it? Anyhow, so if you see something today, and you think, okay, that's like Project X or feature Y in PHP, I couldn't tell you if that's true. So maybe I haven't seen any serious PHP in more than 20 years. So I can't answer your questions there, but I can give you a little bit of insights in what's happening with TypeScript. And funnily enough, that I've spoken about TypeScript now for, I don't know, the last 2 years or so, or even longer. I even run a blog which centers mostly around TypeScript. And that's funny because when I started with TypeScript, I actually hated it. So I didn't like it. And the first contact that I had with TypeScript was back when it was released in 2012, and it was mostly either folks who are coming from Java or C# who were telling me, hey, look at that. That's finally C# or Java in the browser, and also Angular. You know, Angular bet heavily on TypeScript, but they tried to hide the fact that you are writing actual JavaScript very, very well. So this was their goal, to abstract everything under their own kind of DSL or pseudo language. And I didn't like it because I actually enjoyed writing JavaScript. So JavaScript is a programming language that got a lot of hate in the last couple of years, in the last decades even. Some is justified, some isn't. But to be true, it turned out to be a really nice programming language, especially with the latest features. It's a really, really nice programming language. And you don't need to make it something that it shouldn't be. It's its own thing. It's very functional. It's very function oriented. Objects just exist. You don't have to have classes. You can, but you don't have to. And there are lots of ways to express yourself in JavaScript that aren't necessarily related to what you see in traditional object-oriented programming languages. And so people were kind of forcing this mental model on top of me that supposedly came with TypeScript, where I thought, why should I use that? I can express myself much, much, much better in JavaScript than I would by having some sort of syntax proxy. So I teach TypeScript for quite a while, until I guess it was about 3 years ago when I was in my paternity leave, and I was taking care of my son. And every time my son was asleep, which was more often back in the day than it is today, I watched conference talks. And I stumbled upon this person. And I don't know if you've met Anders Heilsberg or if you've seen talks by him. Anders Heilsberg basically defined the last 4 decades of programming. He has created Turbo Pascal. Then in the 90s, he went on to write Delphi, which is basically object-oriented Pascal to write Windows UIs. He was a big influence in C# in the early 2000s. The lead architect of C#, not its creator, the lead architect. And he was also is currently the lead architect for TypeScript. And when you listen to Anders Heilsberg talking about TypeScript, he first and foremost sees it as a tooling layer atop of JavaScript. So it's not something, not like CoffeeScript was, where you write the different syntax and it compiles to JavaScript in some way, or Elm, which is Haskell for the browser. You write Elm, but it compiles to JavaScript in some way. This is not it. They want to stay true to what JavaScript provides, and they want to understand every JavaScript code that there is. And where they can't understand it automatically, you have to provide annotations for them, or for the TypeScript compiler, to make it understandable. So it's basically tooling. It's basically some way to formalize your JavaScript code. And this was something that resonated with me and that I could connect with. Because, I've written my fair share of JavaScript programs back in the day. There was always this point where you had a huge cognitive overhead, because you had to remember everything that was going on in your application so you don't make any mistakes. And that's possible. People who are constantly digging into the code base are very much capable of understanding everything that's going on, even without explicit types. But it's a lot easier and a lot nicer if you can rely on some tooling that keeps track for you and that tries to give you hints the next day, the next week, the next month, or give hints to your coworker when they have to dig into the same code base as you do. And I could resonate with that. And the more I tried looking at it and the more I tried to understand what was going on, it was like, okay, this is actually something that I can get along with. This is something that is so close to JavaScript that it actually feels like JavaScript when writing it. And this opened a totally new way, or a totally new perspective on the whole thing. And it even led me to, so this was the third wave. I found out that TypeScript is much closer to JavaScript than I thought. And it can be this thin layer on top of JavaScript. JavaScript has classes. JavaScript has a module system. There are some constructs that, have been added in the early 2010s to, have something there, because JavaScript 10 years ago was a very different JavaScript than it is today. But right now, TypeScript goes along with everything that comes into JavaScript and tries to formalize the type system on top of it. And I became such a big fan of the type system that I even wrote a book that's TypeScript in 50 lessons. Shameless plug. I'm sorry, but I'm actually very proud of the thing. There it is. It's published by Smashing Magazine. It's a 500-page guide into the type system. So what you learn there is the long-lasting aspects of TypeScript the thing that makes it stand out and the thing that you can rely upon if you're writing regular JavaScript. It leaves out everything that is, craft and crud and basically deprecated already, and focuses on those things that are long living and long lasting for beginners and intermediate folks alike. Okie dokie. Enough with the shameless plug. I want to go into some of those advanced use cases that can be beautifully described with TypeScript. And this is something that you probably have seen in one way or another. It's a routing system. It's something like Express.js, if you're familiar with that, or Fastify, or what I've seen basically every programming language that is somehow able to create an HTTP server tries to get to an API like that, where you define a route and then you get the request in. So you have a callback that you can handle, where you can handle the requests. And I figure the Laravel router has a similar API, but instead of I don't know, of all those dollars, you don't have any dollars. No dollars in JavaScript. If you are for the dollar, stick with PHP. So anyways, those are a couple of, I guess, free relevant lines of code. So it's not that much. It's an if statement and basically we send something. But you wouldn't know. Basically, everything can go wrong in those 3 lines. So even if it's just such a little surface of code that we're dealing with, there's so much that can go wrong. And let's look at it, how we can fix it by using TypeScript. So let's move over to the code window. There we are. So this is Visual Studio Code. I just check if it's big enough, and I hope that Freek will confirm that it's big enough. Okay. So those are some get calls. As we've seen today, we have app.get here, app.get here, app.get here, and those are different scenarios where I added some bugs deliberately, and we try to figure them out because right now everything compiles. And this above here, this is the get function we want to type. So this will be our focus for today, and we want to add types so we can catch all the bugs that are below in those test scenarios. And the first thing that you see, okay, we don't have any types defined at all. So there's nothing explicit, everything is implicit, and since we are dealing with functions there, TypeScript can't infer any types, which means reading your code and figuring out what you meant with your types. So we have to add them ourselves. And let's do that. So the first thing that we do, this is the function get. We are going to type it, and then we can write app.get, and we get autocomplete for path, callback, whatever. Okay, let's remove that. So the path, as we've seen already, let's add some basic types. Path is string. So this is something that we can agree on. The path is a string. If I would add number here, that's a basic type, a basic JavaScript type, I would already get some red squiggles that my first argument is wrong. So let's stick with string, and it's good we can't pass any number there. TypeScript would error otherwise. And then we define a callback function. There's a callback, and we define our own composite type or compound type. Compound type is a type that exists of several primitive types. So where string is a primitive type, this is a type that is composed out of several types. And callback is in that case a function. So we call it callback fn. That's just a naming convention that I'm using. And it's a function type. So I call it callback fn. A function that has a request and a response. So request in, where I get a method like get, put, post, options, headers. And a response object or a reply object where I can send back a response like, okay, status code 200, 404, whatever, all the HTTP status codes. I can send them back and get some responses over the wire. It returns void, so that's a callback that I don't need to return anything. That's the callback function. This is a function type, function signature. The request is of type server request, not severe request, server request. I'm going to type that right now. And the response is of type server reply. Let's call it server reply. That's also something that you can find in JavaScript frameworks that deal with servers. Let's define the server request. That's, I guess, the easiest one. So I have a method, which is a string, post, put, get, delete, options, whatever. And then I add parameters. So that's a param objects where everything that I have here, like colon user ID or colon whatever, I get a params object like here. So I have params where I can access this one property that's being parsed from this particular string. And since since this can be a lot, I just use a record type. This is a built-in type, that a little bit of a helper type, where I say, okay, this is a record that consists of string keys and has string values. Okay, so that means basically any key like params. So this is, even though it says params, this is internally a string key, and then it can be whatever. So whatever possible value there. It just has to be of type string. Okay. So that's that. Then I create the type of server reply. Okay. So reply has a send method. It accepts a status code, which is of type number, like 200, 400, 404, 500, all those HTTP error codes. It returns, again, a server reply. So we have one of those nice chainable methods. And the last method that you have is, sorry, that's status, not send. Sorry, that's status. The last thing that you have is send, where you have, whatever you want to send. That's like the object. It can be optional, and it can be of type any. I just want to send anything that is possible, and it's of type void. Okay, so those are my very basic types. And if you can, if you look down here, the first thing already errors. So this is not possible. You can't have a number for the request method, because if you have an overweight, it tells me a string and number have an overlap. So this condition will be false all the time, because request.method needs to be of type string and not of type number. So in case I want to have get. Same here. Rec status, this is not possible, because I pass a string, but I want to have a number. So this is not possible either. I have to change it to a number. All right, I change it to a number, and it compiles again. Very well. But, that stuff is still wrong. There's still lots of problems there. There's still a couple of problems, couple of errors that we didn't catch, because we are just dealing, with compound types and primitive types. So this is a compound type. This is a function type. String and number are primitive types. As you can see here, this is not possible. Pose is not a proper request method. Post is. Pos isn't. So this should error, actually, because I'm checking for something that there shouldn't be. But my method says it can be of all strings. And there's a nice feature in TypeScript where I can reduce the entire set of strings into a smaller subset. So you have to think of every primitive type, or basically every type in the entire TypeScript type system, as this one set. So set theory comes in a lot, where this one set where every value that is considered part of the set is available. So in the set of number, every number that is possible in JavaScript is located. In the set of string, every possible string is located. But you can subset this. And I can say, for example, let's type the methods. I can have the method get, the literal type get, so the string get. Not the entire strings, but just the string get. And this reduces the entire set of strings down to just one little type, just one type. And the only thing that is possible here is get. All right. And then I can create the union type. So I say, okay, get is a possible value, but so is post. And so is put. And so is delete. Now I have all the CRUD options already here. And then we have options, and we have header. I don't know if there are any more. I guess there's a seventh one. I can't remember. But for the sake of this example, that's all you need to know. So I can subset the entire set of strings into those 6 particular strings. No more strings, just those 6 strings. And I take this type and I substitute my string of method with methods here. And suddenly, dunk, here I have another error. Request method is pose. That's not possible, because pose and everything in methods has an overlap. In fact, I can remove that and check what do I have, which options to have. So TypeScript gives me autocomplete on all valid options from this particular type. So I can say, okay, get in that case. Or let's keep it with post, just for the argument's sake. Which is also nice, because if I say else here, and I hover over rec.method, you can see that post has been extracted, because I dealt already with that in the if statement. So it just can be everything except post. It can be every other string in my methods type except post, because I already dealt with post. And I can play this game for every possible method until there is none anymore. And this is called exhaustiveness checking. So TypeScript knows which values are possible. Since I reduced the set to a very, very small subset, I reduced this particular set. And with that, suddenly TypeScript knows exactly which possible values are there and can tell me exactly which possible values I have handled already or which I have to handle, which is also nice because if I say, okay, let's else if rec.method is get, and let's do a couple of those, zack, 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 zack. So I get already errors if I handled it twice. Let's say put, let's say delete, options, and here we have headers. I guess those are all. An interesting thing happens once I'm down there. Sorry, I forgot the code. Rec header. Thank you very much, TypeScript. It's header. So something interesting happens in the last else branch. Okay. Suddenly rec.method becomes never. And this is interesting because I already defined all possible cases that rec.method can be. If for whatever reason this method here jumps into the else branch, into the last else branch, TypeScript knows that this is a situation that can never happen. So this is a value that can never happen. The only thing that can happen then, which is the only valid thing, would be raising an error or throwing an exception in OO speak. And this is the only thing that can happen at this place. Everything else can never happen. And TypeScript tells me that with the bottom type, never, which means this is a value that doesn't exist. I exhausted all possible values that are available in TypeScript or in JavaScript, and this one is not in there because you defined the TypeScript system like that, and I can tell you, or TypeScript can tell you that at this position, there's something wrong. There's something seriously wrong, handle that. And this is also something very, very interesting in TypeScript. So I can exhaust all possible options just by the fact alone that I can subset this big set of strings into a very small set of strings. Alrighty, let's get rid of all those things and do the same thing for several replies. So I have status code here, and I already prepared a type down there. I'm not going to type that. That's all possible status codes from HTTP. Figure out for yourself which one is the teapot. I can't remember, but I guess it's one of the fours. 499 maybe? I don't know. So what I can do now, instead of number, I set it to status code. There you go. And suddenly those two methods error as well. So it's not 20 is not possible. It has to be one part of the union of valid numbers. So those are all valid numbers for status code. There you go. Those are all valid numbers for status code. So those are valid. The others aren't. That's why I get an error here. So 20 is not a valid status code. It's, let's say, 2.1 maybe, and here let's say 4 whatever. There you go. Those are valid status codes. Very good. So we already removed a couple of errors. So we are just able to get to the right data type and then a proper subset. This already gives us a lot in terms of correctness of our program. But there's still a little bit more. There's still something more that I want to fix that bugs me a lot because, something like here, that also can't happen. I can't define a get callback and check for post. Post should not be possible at this particular place because I'm dealing with get. It's something entirely different if I have a post method defined, app.post, and then rec method is post, or rec app.all, where I handle all requests. Then I have to check for the method. That's true. But in that particular case, rec.method can't happen. And I want to have an error for that. Because if I don't get an error for that, I have a method that doesn't work. This jumps into, so this is an if branch that never occurs, and I never send a response because here I have get and here I ask for post. That can't happen. So I want to catch those errors. And there's a feature for that called generics. And with generics, I can subset methods even more. So what I do here is I have my server request here, and I say, okay, instead of all those methods here, I pass a generic type variable. It's pretty much like an argument in a function, okay? Where I say, okay, you have M, and M needs to be a subset of methods, okay? And maybe I set the default value, which is just all methods that there are. So I say m extends methods and is as default value all methods. And I take this just like a function argument and put it here in methods. And suddenly I get a little bit more flexibility. So I can have a type that's called server request get, which is server request, and I just allow get in here. And suddenly, if I have overhead, I see method can only be get. Or let's do another one. Type server request post is server request post. You get the idea, and suddenly, okay, the only method available can be post. I can also do another union, a subset of this set, a subset of the subset of string, like put, okay? And suddenly can be post or put. You know, I can be very flexible with that, and I can define my types very well by just adding this generic argument. So it's a way to subset again the subset that I already did. All right, but what I want to do, I want to carry it over from callback. So server request is defined here, and here I have the callback function where I say, okay, I have also m extends methods, and I want to pass that along to, oh, sorry, wrong one. I want to pass that along to server request. There you go. M. Suddenly I get here an error. Of course, I need to define that here as well. And here I'm already in the get function that I define. So I say, okay, here I want to have get. Okay, so get is the only possible argument or the only possible method that I allow when I call app.get. And now I get all those nice errors here. Post. There you go. Those errors. Those are things that I want to handle. If I'm in a get callback, I don't want to check for post. That's something that I don't want to do. Alrighty, so let's change that to get. I just want to change that to get because what I'm doing now is I add another function that I also have to implement at some point in time. You know, I'm lazy. I'm just doing types. I define a post function. There you go. Whoops, sorry, and I say it's post. Then I hooked it up into my app. There you go. I have an error somewhere. And here suddenly I have post available, and what happens? Rec method post suddenly is correct. So it's as easy as that to define another callback. Let's define also an all method where I say, okay, all just handles everything, so it handles all methods. There you go. Hook it up, and now that I allow all of them, if I define app.all, so a wildcard, function rec res, totally improvised, by the way, rec.method, you know, can be everything again, because every method, because I'm in this one particular callback that allows those. And that's how I can even subset further what I already subsetted. And I can be very concrete and very explicit about what I expect at this particular point. And suddenly when I work with my framework or with my Express server or Fastify server or what else, those errors don't happen anymore. So this is also something that could slip a code review, or maybe could slip some tests, but I get immediate editor feedback the moment I write it. And this is something that excites me a lot. So this is really something where I say, okay, this is helpful. This can help me a lot while developing. But there's even more. So there's even something more that bugs me a lot, because I don't know if you recognized it. Third error. Here's user ID with a capital D, and here's it with a lowercase d. And this is an error. Wow, how can you catch that? So here I have colon user ID already. You know, it's somewhere in the string, so it should be represented somehow here as well. And guess what? We can do that. So we can work with that. I go back to my server request type, and then add another type variable, which I call p, and it extends string. So this is short for short for path or parameter. Move that, and I add p in here as the keys of record. So I can create a type that's, I don't know, has user ID, which is server request of get and of user ID with a capital D. And suddenly I get a type that has this concrete method and has a record, so which creates an object where the key is user ID with a capital D. So I want to create a type like that, and I want to carry it along with all the other things that I have. So what I do here, I do here the same thing. So it's extend string. There you go. I call it with M and P, and suddenly I get some trouble here. So I have, of course, pass that argument here as well. And what I do here now, let's go on with the multi-cursor. I say, okay, I have also P extends string. There you go. And I pass P along. Okay, pass P along. All is well. So there's a typo. There you go. So right at the moment, nothing happens because I extended everything from string. But what I can do now is, for example, saying, okay, I have the argument user ID, quotes user ID, and this gets passed along into the params object, and suddenly I get an error here. Okay, this user ID does not exist in the one thing that I defined. This should throw an error. So this is already very good. So I can every callback that I can define the arguments or the parameters that I expect with a generic type variable. Okay, good enough, or good, but not good enough for me. So we can do even more. And let's remove that. Because what bugs me is that I have to define it twice. So it doesn't matter if I have to define it here and here to catch it here, or if I have to define it just here to catch it maybe never. So this is, bugs can happen in all scenarios. I want to pinpoint that particular bug. I want to make sure that I catch everything that there is. And the information is already here in this a particular string. There's already colon user ID. I want to extract this, and I want to be sure that I can work with that and get type safety out of that particular string. And I can do that. And this is something that's mind-blowing, in my opinion. So just a little excursus in generics. I have a function called identity. T takes one argument that is of that type T, and it returns the same thing again. So everything that it does is returning what I get as a function argument. Why am I doing that? Let's say you have test variable, whatever, and I call this identity function and I bind it to string upfront. Then I can only add strings here. So 2 is not allowed, but hello Laravel Meetup is very much allowed. Okay. That checks out. What is the return type of identity? It's string, of course. I added string here as an explicit type annotation for this generic variable. But what can I do now? I can just remove string. And the big question is, what's now the type of test var? And it is hello Laravel Meetup. So if I don't specify explicitly which type I'm looking for, TypeScript infers it from the arguments that I pass. So in that case, I'm not passing just a string. I'm passing a very specific string. Think again of those sets. I have those big sets with all the strings, and I'm reducing it to one particular string, hello Laravel Meetup. And this is a type that I get back. And this is a type that I can work with. So let's remove that. We don't care about that. I have here the same thing. I'm adding a type /API/user :user ID. I'm interested in this particular string, not any other string. I'm just interested in this string, and I want to work with it. So let's go up into basically all my callbacks. That P, let's pass it for now. But what I'm more interested in, let's take those paths and set them to P. So the moment I do that, I get a couple of errors, basically down here, because TypeScript takes this string value here, takes it, and creates a record out of that. So the only thing that, so it takes this string and puts it into this record, this one particular string. So that's already great. I can take this string from up there and move it around in my code base. That's good. But now I want to transform it. And for that, I create the type that's called parse route params of P, and I just return P for now, just so my code doesn't break, and I add it up there in my callbacks. So there you go, parse route params of P, That looks good. So still nothing has changed. But now I'm working with the P. And the cool thing is, I told you that I can check if one type is a subset of another type. And I can create those checks even further. I can even further work with those strings. In that particular case, I check if this string that I get in there, let's call it it's extends string, that's great. If this one is a subset of one particular string, which is literal. So this is just like the JavaScript template literal. It starts with a slash, like those route calls in here. Then there's any possible string that there can be. Just any string, whatever the string, doesn't matter. But it's followed by another slash and by a colon, just like those param declarations colon user ID here. If that's the case, take what comes next and invert it into a variable. So I take the string that is down here, so starting from the colon up to the end, I take this particular string, extract it, and suddenly I have this available as a type. And if that's the case, I say, okay, return param. Okay, it's return param. So this is like the ternary operator in JavaScript, but in the type system, return param, otherwise return never. And suddenly I get errors again, but this time, look at that. User ID does not exist in type record, user ID with a capital D. Did you mean user ID with a capital D? I even get an autocomplete or a suggestion for the one thing that I meant. I guess I can quick fix it. Look at that. I can say, please fix all detecting spelling errors throughout my entire code base. Because I was able to we had this entire set of strings, then we had very, very small subset of strings, and now I have something in between. I have a spectrum of strings, and this is for a programming language like JavaScript, where lots of things are just strings. That's gold. That's pure gold. So this is something that just blew my mind, to be honest. Let's take it a little bit further. Let's go recursive. So I can have something, like order ID as well. For all users, I have orders and then order ID, and suddenly this doesn't work anymore because, hey, I just have, so it takes something entirely weird out of that. Because, it doesn't deal with multiple colon arguments in there. But I can adapt my type. So I can say if P extends blah, blah, basically the same things here. Look at it. If it extends the same string as here, but it's followed, so there's another slash, and it's followed by some rest, whatever that rate is, take the param and call a recursive argument to pass route params with the rest. There you go. But with another slash. That's just, because I split strings, I have to recreate them. Otherwise, do whatever you see here. And suddenly, if I hover over params, I get a union type of user ID and order ID, so I can use user ID as well as params. There you go, order ID, and I have entire autocompletion with just that it can feel a little bit like writing regex, except that it is kind of readable if you understand the type system, and this is just beautiful. So this is something that makes the type system of TypeScript so unique, because you not only can deal with all the values, but you can deal with a spectrum of values. Not like the entire set of strings, not just particular strings, but a spectrum of strings. And you can recreate and redefine all those strings and extract information out of that on the go. And that's a couple of type information up there. That's, I don't know how many lines, 20 lines of TypeScript meta programming. And there we have, I don't know, a couple of annotations, not that much, just a couple of annotations. And down there, I'm just writing JavaScript. I'm just writing regular JavaScript. It's just JavaScript. It's a type layer on top of JavaScript. And I can do everything that I'm used to from JavaScript. And this is what made me a TypeScript fan. Okay. That's enough for the live coding. So again, to sum it up, I want to quote Anders Salzberg, who said that I guess it was built 2017. It's not that JavaScript has no type system. There was just no way to formalize it. And this is the goal of TypeScript. TypeScript is a way to formalize JavaScript, and that's great. So you can do a lot of things already with that. For me, that means TypeScript is JavaScript. Also, it means that if you have any new language innovation, any new language features, where you say, "Wow, TypeScript gives us that great of language features," that's actually happening through ECMAScript, the standards body that standardizes JavaScript and JavaScript derivatives. So Microsoft is part of TC39, the standards committee that defines ECMAScript, but there's not a single feature that comes into TypeScript that hasn't passed a certain stage in the standards body. So language innovation happens there. But type system innovation happens with the team and through use cases. So the goal of TypeScript is to be able to formalize every possible scenario that there can be. And they come pretty far. There's still a couple of things that can't be typed, but I think that will happen in the future. And of course, tooling is a primary citizen. You've just seen that. So I'm just trying to create a couple of types in the editor because I long for those red squiggly lines. If you look at my book, you see it's red squiggly lines all over. Even this one little band is just, it's a red squiggly that you can use as a bookmark. So it's all about the red squigglies. That's what TypeScript is about. Finding errors before your users do, basically, in production. So how are you going to test your software in production? Alrighty. Okay, that's about it. There are a couple of resources. So I'm making sure, if you follow me on Twitter, that I'm sending you a link to the slides just after, so you can read a couple of articles. You can find information on my book. So I have an article on low maintenance types, which is very interesting because you can define a subsystem of types that are maintaining themselves. So you don't have to do that. There's an article on Smashing Magazine Dynamic Static Typing that sheds even more light on what you've seen today. I've written a series called Tidy TypeScript, which is just about false friends in object-oriented programming. So since I've seen today for the first time that you in PHP have everything from interfaces to namespaces and everything in between, that's cool, that's great. But things that work, in Java or C# work pretty much different in TypeScript. And the Tidy TypeScript series tries to shed some light on that. Last but not least, there's a guide on advanced TypeScript features. I guess it has about 20,000 words right now, which is also on my website. Be sure to check that out. And with that, I want to say thank you very much for having me today. It has been a blast for me. So I love talking about that stuff so much. And yeah, that's about it. If you have any questions, hit me up on Twitter, or I don't know if you do a Q&A right now. But in any case, that was great. Thank you.
Thank you, Stefan, for that very enthusiastic introduction to TypeScript. It's very clear that this makes you very, very happy and enthusiastic, which is a joy to see.
Thank you very much. Yeah, so when once the ball dropped, it was like, oh wow, you can do really great things with that, and that's what excites me so much. So it's really something that makes my day-to-day work easier. And just with the features that came to TypeScript in the last release, it was like, okay, now I'm basically done. So I don't need to do anything else anymore. This is the way to go.
Yeah, I've done some TypeScript myself, but not as advanced as some of the stuff that you see. I think the most advanced stuff that I did was using generics and something like generics. And I still remember that feeling that, if I just get all the types right and there are no red squiggly lines, probably it will just work. And it happens every time. If you just fix the type errors, probably everything is fine. And that's like a magic feeling.
Absolutely. Totally agree with that.
Yeah. And yeah, I think in PHP we have a basic file type system, but something like generics, we should really, really have that as well, because that unlocks so much possibilities. But I think that you saw that you can basically introspect certain strings and say, like, hey, this should be a type. That's mind-blowing. And I saw it in the chat as well, that for some people this was like, whoa.
I haven't had an eye on the chat, unfortunately, but it's something I'm going to check out right now. So I'm really curious what people think about that.
Yeah, I see a lot of clapping hands and and hearts. So
great. Okay, you get them back. That's great.
Yeah, unfortunately, I have to go, so I have to wind down the stream. But yeah, you can certainly go on the chat and answer some people there, or talk with some people that want to know more. Yeah, I've also read a big part of your book, and I'm a fan. I am not paid to say this, but if somebody wants to go deeper into TypeScript, the book is really an excellent introduction.
Thank you very
to
much.
all of it.
I always feel so bad for doing all those shameless plugs, you know, but honestly, I really love what we made with that thing. So it's a very unique book, and I'm very proud of it. So yeah, maybe it's something for you folks too. So there are lots of TypeScript resources out there. This one is a little bit special. So yeah, maybe you like it. It's great that you like it, Flex. So that's great. Thank you very much.
I'm pretty sure that other people like it as well. Should they be interested to go further into the wonderful world of TypeScript? Okay, Stefan. Yeah, thanks for being here. I'm pretty sure. Yeah, we'll talk some more in the future about
hopefully.
About TypeScript. Okay, see you, man.
Alrighty, cool. Bye, folks.
Bye. Okay, that was it for this meetup. And I hope that you enjoyed the talks. If you want to be kept in the loop when the next meetup is, either follow Laravel WW Meetup on Twitter or go to meetup.laravel.com. We aim to have monthly meetups. So next month there's already a next edition. And I've planned it for March the 23rd. It's already up on the site. And if everything's good, I have a slide here that I can use to show you who the speakers are. Let's bring that up. So it will be a Spanish edition. We have Miguel, and he's going to be talking about some cool ways to sign into a Laravel application. And he'll show you how to use stuff like Face ID and Touch ID easily to authenticate yourself. And then the next speaker will be Kaneko. He directed the new Laracon Online website. If you already visited that site, then you know that there's a pretty mind-blowing site, pretty cool graphics, some awesome effects there. And Kaneko will give us a tour of how that site became to be. So 2 interesting talks again. I'll see you again on the March the 23rd. Yeah, and that's basically it. So have a nice evening, and thanks for watching. Bye-bye.